Morning, everybody. Thank you for joining us today. This is going to be the third of our webinar series on OpenShift on Azure. And during this webinar, the last of the series, we're going to be covering more like a demo with you and more on real life scenarios where you have application, where you're looking at an application in the real life case and seeing how microservices and how OpenShift actually applies. So if you are an online company today with an online presence, it would mean that this is going to be critical in not letting any of your services for multiple users drop. And even if there is such a drop, it lets at least most of the majority of the users continue using the services. And that's where microservices play such a critical role. You'll see a real life case scenario today. Pranesh, who is our speaker from the series, from Rhipe, our CSP from New Zealand. He's going to be continuing on this webinar series, and today he's going to give us a demo on CoolStore. I'll let him cover the agenda as well, but we're going to see some great examples of how this comes into a real life play. So Pranesh, thank you for joining us, and I leave the stage to you.
Excellent. Thank you so much, Sindhu, and welcome to all our partners and our customers. Very good morning and good afternoon to wherever you're based. And I'm actually very excited about this webinar in particular, is because this is where the rubber hits the road, as many would say. In the first two webinars, we essentially covered off, what OpenShift is. We spoke about the deep dive architecture, how containers actually work, what are the benefits of using microservices. And this is where we actually stitch all that together and put a real world life application in place so that you can actually see the benefits and how you could actually apply the same concepts within your environments and your applications and the way you manage and deal these applications, right? So the actual application that I'm going to be covering today is called a CoolStore application. It's a microservice application which is composed of a number of services which are built using a modern framework. So it's got Node.js, it's got Spring Boot, it's got Apache Camel, JBoss EAP, JBoss Web Server, and a couple other integration or integrated applications that I'll show you. So the application is built using different languages as well to explore how microservices architecture patterns are used. Components are built and tested in containerized environments, right? So what I'll be covering is the actual application. I'll take you through the containerized microservices that make up the actual application. I'll talk about the different agile integration points and how we actually bring external sources within the application and how they actually work. I'll also cover the service resilience and fault tolerance of the platform in terms of high availability and, having pods fail where your application still runs. Those are one of the big benefits of what the OpenShift container platform can actually offer you. I'll also take you through creating on-demand environments, where developers want an on-demand environment to, go away and code pieces of an application. And I'll also speak about, increasing your delivery speed with continuous integration and continuous development, which is a key area when you're actually pushing out applications and pieces of that application into, pre-production, UAT production. And then, of course, I'll go through and round up with my call to action. So without further ado, we'll jump straight into the demonstration. Okay, so the actual CoolStore application, it's an online shop for selling products, and it's an actual application that's actually used in production, and we're lucky enough to actually get the source code so we can actually demonstrate this for you, right? It's a web-based application. It's using AngularJS, Node.js, Java with multiple frameworks, Spring and Java EE being the more prominent ones in this application. It has a very well-defined microservices architecture, and it's deployed using containers managed by OpenShift container platform. So just to give you an idea of what the actual services that actually make up the actual cool store actually look like, we've got your shopping cart service, which is essentially everything in here, and within your shopping cart service we've got your different catalog items over here, as well as an inventory service which pretty much tells us what's in stock, how many items are actually left, and that reports to our backend system that actually maintains our inventory for those particular items. So I touched on that microservice architecture bit in the previous slide, or simply microservices. So it's essentially just a method of developing software, right? So the main idea behind this is to break down the traditional monolithic applications into smaller pieces and independently deploy software to talk to each other, right, through a well-defined, lightweight mechanism as such, to deliver the same functionality, right? So, some of the main reasons why we'd actually do that is the flexibility in developing those services independently and concurrently using multiple technologies, as well as it's obviously a faster, much simpler way of deployment and rollback with these small services. But that also gives you more resilience as well, right? So when the services fail, instead of the entire application failing. And it is very, very well suited for continuous delivery and integration, which is something that I'll cover to the latter part of this application, or a demo of this application, right? So just to actually break down what the actual architecture actually looks like, and all these different components that actually make up the application for us, right? So it's a microservices application, and it's composed of multiple services using different frameworks and programming languages. So the actual catalog service is running off a Java application running on JBoss web server, Tomcat in specific, and MongoDB. So this piece actually provides the list of products and prices, right? We then have your cart service as well, which is another Java EE application, also running on JBoss EAP, and that essentially manages the shopping cart, right, for each customer. We then have your inventory service, which is also running a Java-based application running on JBoss EAP and Postgres. And that actually serves the inventory and availability of data for availability data for the products, right? We then have your cool store gateway, which is essentially just a simple Spring Boot and Camel application using JBoss Fuse integration services, and that acts as an API aggregator for other services, right? And then we have a web UI front end based on AngularJS and running Patternfly, all running within a Node.js container. So I just want to give you a quick idea of how I've actually deployed this application. So if you can actually go to that address, you could pretty much do this yourself. It's readily available. You could fork this from GitHub and actually deploy the application within your own OpenShift environment, right? So essentially, it'll take you through pretty much what the services have been deployed, which I've just covered off with you, and then that's pretty much the application there. But this is probably the more important part here, right? In actually deploying the actual application. So obviously the biggest prerequisite here is to make sure you stand up an OpenShift cluster. Obviously this one's actually deployed on Azure. So I've actually deployed the infrastructure for the application. I've built my OpenShift cluster already. And this is essentially what all you would need to actually deploy this actual application that I'm actually describing in this demo, right? So you could actually go through this, and then you'll end up with the exact same application that I've just built for us in this demo. So next, I'm actually going to show you the actual application because I have that obviously running now. So essentially, we have your shopping cart service here. We've got your catalog items here, and we've got your inventory items here, right? So essentially, the list of products in here, right, in the Cool Store online shop is provided by the catalog service, right, which is up here. And the web UI makes an API call to the Cool Store gateway, which is the API aggregator, and the Cool Store gateway redirects the call to the catalog service, right, to get a list of all the products, right? So the number of products in stock here, which is displayed under each product, is provided by the inventory service, which I pretty much showed you earlier. So what I'm going to do here is I'm actually going to click on a particular item, and I'm going to add something to my shopping cart, right? So let's have a look here. This one looks pretty cool, so let me add on this. So I'm just going to add this to my shopping cart. I'm going to go up here, and it looks like I've added this item already, so it shows me that I've added that item. May have added this earlier as well. That's how I've added. That's how I've got two items. So essentially, the cart service actually provides the shopping cart functionality for the actual Cool Store online application, and that keeps track of all the customers' shopping cart status. So what I'm going to do now is that I'm actually going to choose a particular item and try add something to my shopping cart, right? So let's have a look here. This one looks pretty cool. So let's add that to my shopping cart. So I click that up. It shows me that I've added something to my shopping cart. Gives me the total. I'm just going to click on the shopping cart now to see exactly what it's actually put in there. So this is essentially the cart service, which provides the shopping cart functionality for the Cool Store online shop, and this essentially keeps track of of customers' shopping cart status. So the next thing I'm going to do here is actually jump into my web console of OpenShift, and I'm just going to go into the Cool Store project, and under that's obviously my application that's been deployed, right? So just an overview of this, so you can have a look That's the cart, the catalog, the cool store gateway, the data grid, the dashboard, the inventory, pricing. So all these here are different containers that run these services, right? That are all interconnected. So the one that I actually wanted to pull up here is the actual web UI, right? So I'm just going to pull the web UI one up. So essentially the web UI container, which is what we're looking at now at the moment, that's essentially is the front end of the application, the cool store application that was built with Node.js and AngularJS, and that provides pretty much the web experience that I pretty much showed you over here, right? So if I just click back here on the actual overview, so all the other things in here, right? Those things like the cart service, the inventory, the gateway services that I also demoed in the previous step, these are all running in separate containers, right? So they're running all in separate containers. You can see that. They're running in their own pods, and it's just single replicas, right? And it's displayed within this project, which allows them to get deployed at scale independently. So the other thing that I want to cover off here quickly whilst we're here is the actual inventory service, right? So the inventory service is essentially also running a Java EE application running on JBoss EAP, and it uses Postgres database to persist data, right? So JBoss EAP and Postgres each run in their own containers, right? So I just want to open up this pod here for the SQL Postgres SQL stuff, just that I can show you how this is actually running here. So this is obviously this is running in a container for Postgres, and you can see the sort of stuff we actually get out of what the actual container actually looks like, right? So we've got all your normal characteristics that you would find within a system. You would find, you can look at the different inventories. This is actually showing us, the status of the containers. Obviously they're running, and if there have been any container restarts, right? So, whilst we on here, probably a good thing to just touch on would be, how a microservice can actually be deployed on JBoss EAP, right? So OpenShift, it provides a set of middleware services in order to simplify, running traditional and cloud-native applications in containers. So microservices can be deployed on JBoss EAP running inside a container. Alternatively on other applications, other web servers like Tomcat, JBoss web server, or even as a fat jar directly inside a container like Spring Boot when running on OpenShift. So an OpenShift service is a group of containers, right? I think we've obviously covered that previously, but pods actually, in fact, that are running and provides internal load balancing between them. So, services are cheap and you can have many as services as you wish within a cluster. And Kubernetes services can efficiently power microservice architecture, right? So backing containers can be added to or removed from a service arbitrarily, while the service remains consistently available, so enabling anything that depends on the service to refer to it at a consistent internal address. So currently, like for most of these services that you see here, we just, there's only one container running, so there's just one pod. So if you look at the inventory one, there's just one running there. So when the actual inventory is actually scaled to more containers. What OpenShift would actually do is automatically load balance the request between the inventory containers. So the next thing I actually want to show you whilst we're here as well is the catalog service, right? So I'm just going to pull up the actual catalog container, and I'm actually going to click on the deployment, which is the latest deployed container or pod in this instance. And I just wanted to click through some interesting stuff here, right? So if I click on the actual environment, shows me what's in environment. Have a look at some of the metrics. You could actually see stuff going on in here. The metrics is very, very powerful part of what OpenShift Container Platform actually gives you. We can also have a look at the logs, and the good thing about this is you don't have to, you don't really need to log out of this or into another system to actually look at what your actual logs actually look like for the actual catalog, right? So I'm just going to go back in here as well. While that loads up. Have a look at the environment. Have a look at any events. Look at my configuration. Yeah, it's pretty neat. We can pretty see everything that we would normally see. Like I'm not sure if you followed me in my last webinar where I was doing a lot of stuff on the command line. But this essentially shows you the same thing, but through the web front end, right? So yeah, let's have a look at some of the metrics that's collected there. I think I've actually covered that off for you already. Let me just open that. You can see we can actually go into the actual Java console if we wish to. If we click here on the terminal, that takes us to a terminal, and yeah, quite comprehensive stuff that actually comes out of the actual platform, and then also shows us about things like your consumption for your memory, CPU, network. Quite neat. Very, very neat dashboard. So the other thing just to note as well is this is based on OpenShift 3.11. Obviously, you may or may not be aware, but OpenShift 4 is actually coming, or it should GA in the May-June timeframe, and there's some really exciting stuff that's going to be coming in there as well. So look out for that one. So the other thing that I also want to show you whilst I'm here is the actual the cool store gateway, right? So let me just open that up quickly. Just open that. So this essentially in this particular pod. So the JBoss Fuse integration service, it obviously provides a set of tools that enable development, deployment, management of integration microservices with OpenShift, right? So in this particular one, the Cool Store Gateway, right, is a Spring Boot service. It actually uses Apache Camel, if I'm not mistaken, to aggregate API calls to other services like the cart service, the catalog, and the inventory service. And it also controls how that actual data passes through to those services, right, by applying the required data transformation, failover, audit, load balancing, and etc. I just thought it would be good to cover that piece off whilst I was here, because it's quite a big application in terms of what's being actually delivered over here, but you can see in OpenShift and using that whole microservices architecture how we can actually break down that application into much more smaller pieces that work together to deliver the same functionality. The other thing that also may be noteworthy here, worth noting here is actually what the gateway REST endpoints actually look like as well for the application. So in this particular one, I'm going to pull up the actual one for the Cool Store gateway again. So I'm just going to open that up for us, just to give you an indication of what this actually looks like. So you've got all these API, gateway, like the endpoints here, and so let's just pick one of the things, right? So you can look at the pretty much what that step-by-step breakdown of that endpoint actually looks like. So you've got your options in there, you've got your post and your get for finalizing shopping and the cart process payment, all the way down, right, in terms of all the things that you would interact with for that whole process of that shopping cart, right? And that's essentially what that looks like. I thought that would also be worth noting whilst we're on that one. So pretty much we're using Swagger for that to actually see what that actually looks like, and it's pretty much it's a very neat service, and I thought it would be good to actually show you how that actually works. I'm just going to jump back in here, back on that Cool Store gateway. Just going to open up the latest deployment of that. Just open up that container. I just want to open up the Java console here to show you what that looks like as well. So you can see it's actually a camel application also running in there. I just want to click on the route diagram here to show you what that actually looks like, right? So that pretty much shows you, the different routes and the processes and what's actually involved in there. And if you look at all the different things in here, so these are essentially just the different structures within here, and it also shows you your message counts, right? So you can see all your different messages that as they traverse the application, we're able to to actually have a look at it and see what it actually looks like. Another cool part that I thought would also be good to demonstrate is how do we actually also scale the application so that you could actually handle more requests that are actually coming into the actual application, right? So I'll just click overview here. So I'll just pick something, right? So let's just go and look at our inventory, right? So at the moment, we've just got one pod running here, right? So what I'm going to do is I'm just going to pick this up and scale this up by 1, right? So scaling to 2, and at the bottom here you can see it's creating another container for me, right? So what this will essentially do is run up another container, and the platform is smart enough, as in the Red Hat OpenShift platform, smart enough to actually load balance the requests coming in between these two containers. So we could cater for, a much higher workload peak that's actually coming in. So, we can actually scale our application much better, right? Much more smarter. So, whilst we're on this note as well, if we had to be running this application, say, on-prem, and we were scaling this into Azure, right, we could actually spin up different containers based on affinity rules as to where we want those actual pods actually running, right? So we could run some of them on-prem, we could run some of them on Azure, we could scale it on Azure, we could scale it back. The platform's quite flexible in terms of that, right? So one thing I actually want to show you here is I'll jump back to the store, and you can see our inventory items here. It's actually telling us we've got items in there. What I actually want to do is I actually want to jump back to the container platform for that particular service, and I actually want to kill the service. So I actually want to kill the inventory service, right? So I've pulled it down to 1, so what it'll do is it'll terminate that container that was running, the one that I actually scaled, and it's brought it down to 1, but I actually want to completely wipe this out. So what OpenShift will tell me is, are you sure you want to scale the inventory to 0 replicas? This will stop all pods for the deployment. Yes, I want to scale that down. So it's going to terminate that as well, right? So once this is terminated here, so 0 pods, so this service is actually dead, right? There's nothing running here now. I want to jump back to the actual application, and I just want to refresh this to actually see what actually happens here, right? So you can already see that it's already telling me that inventory is unavailable, right? But the cool thing to note here is that although I killed that piece of the actual application, which is the inventory, the rest of the application is actually still running. It's still running fine. And I can probably still, go in and actually still order things. Like I could add that to my cart, and that's all working. That's all cool. I can see my cart's been updated. It's showing me the right items. The only thing is I can't actually see the inventory, right? So that's one of the cool stuff for resilience and fault tolerance in the platform, right? So although that service was actually killed, the actual application still works as expected, apart from the actual inventory not being available, right? So I'll just hop on back to OpenShift, go back to that service, the inventory service, and I'll bring that back online, right? So that just takes a minute or two, spins the container, instantiates it, and then pretty much creates all the the configs there already, so it'll be able to come online and then back into the application. So the next thing that I actually want to cover off here is creating an on-demand environment, right? So let me give you a hypothetical situation, right? So say there's a Jira issue that's signed to you to fix a bug, right? In the inventory microservice, which runs on JBoss, right? Whatever the scenario may be, right? So, and you need to deploy the exact version of the source code containing the issue in an environment to investigate and possibly correct the problem, right? So since ordering new VMs takes about 6 weeks, and I'm pretty sure you all can back me on that, you want to see how you can use OpenShift and containers to quickly create an environment for yourself to deploy the code and start working on the issue, right? So what I'm going to actually do here, we've actually got a platform called GOGS, which is a source code repository system that's deployed as a project here within OpenShift. So, down here you can see I've got, all the different projects here. So the one that I'm actually going to click on is this one. It's my CI/CD pipeline, right? So I'm going to click onto that, and I can see GOGS here, and I want to click on this here, and I'm actually going to sign in. So this is our source control system, right? So I'm actually just going to log in here quickly. And I'm actually just going to explore this. So I could see that something's already being. So this is the team cool store project. Now we want to make sure that we actually fork the code as ourselves, because I don't want to commit any changes that I make into the master branch, right? I want to make sure I can, actually do it in my own branch, right? So I've already created a fork of that here, and if I click into it, I can see that I pretty much created a fork of the master, right? So if I wanted to fork this further, I could, go in here, give it a name, and pretty much fork that. Okay, here. So it can't to its original owner. Okay, so that's all good, because I've already forked this here in my previous one, right? But we can actually see that that branch is actually created under myself now, right? Which is all cool. That's what I want, right? So what I'm going to do is I'm going to actually go ahead and copy that URL, because what I want to do is I want to actually create and deploy this source into a different project, right, within OpenShift. So what I'm going to actually do now is jump back to the actual OpenShift web console. And what I've actually done is I've created a developer project. So the admin generally hands out the rights. And if this particular user has rights, you can actually create projects, right? So it's completely role-based access. So the admin can create different users for different developers or testers within the organization. So what I'm going to do is I'm going to go ahead and go into this developer project that I've actually created. And there's obviously nothing in here, right? It's blank. You can see there's nothing in here. So the developer wants to provision this application, right? In this project using that forked repository that I actually did in the previous step, right? So the developer can essentially deploy an entire application with all its components at once, right? So things like the service catalog by default, among other things, the templates that are available in OpenShift, the namespaces, etc., they are all global and available to all the projects and users, right? So however, in this particular project, we have a template for inventory service that the developer has created, right? So you can deploy project templates by clicking on Add to Project. And so we can go select from project. It's the developer project. Let's select the inventory because that's what was selected. It's a microservice AngularJS. I'm going to go next. That's the actual repository, right? Now what we could actually do here is we could essentially replace this with the repository that we want to actually work with, which is the actual developer one. And that's the one I forked, right? So we can go create, and then the inventory goes in, gets created, and then we can go to the project overview. You can see that's actually building. If all goes well, that will actually build the actual project for us. And then you can see there's a pod that's actually come up as well. Oh, it should come up shortly. And then essentially what's happening now in the background here, right? So as part of the OpenShift project, there is there's a project behind the OpenShift platform that's called Source to Image, right? And that gets started, and what it actually does is it clones the actual source code from the developer's forked Git repository, and it starts building the actual application, right? So I just want to look at the configuration here, and you can see there's things that have also already been allocated to this. So this will eventually come up, right? And then what this does is it actually gives the developer the ability to actually run. So there we go. So that's already come up here. That's running now, so that the actual developer can go and do whatever they want to do within that application. They can fix things, they can run things. It's not running off the master, it's running off his own forked version of that, and in no way he's going to affect anything within that master branch. That's A. The second thing is, traditionally, if the developer needed to go and provision something like this, they would essentially create a ticket, they would go and request IT to actually build in a VM, then they'll tell IT to actually what they actually want running on that particular VM, what libraries they need, what applications they need, just so that they could actually then use that to start building the application and start working on it, right? So pretty much this is done within a couple of clicks, and you've got a full self-service capability in the OpenShift platform. So the developer can actually pretty much do whatever he needs to do. He can select the environment, he can select this, what he wants to actually develop in, he can select the runtime, and away he goes, right? So this actually shows you how much time the OpenShift platform can actually reduce for you as well, because you can actually start developing and fixing applications much faster, which means you can get your applications out much faster. So, when you can actually provide that to the business in reducing your time that you get applications out, it's a big win for your team, for your organization, for your business. So just jumping back to my web console, my projects. This is going to bring me to the last bit of this demonstration, right? And it's an exciting one because it's CI/CD. So what I just want to get on to here quickly is take you through the projects that we currently have, right? So we've got the developer project here. And this is essentially the developer's personal project for creating on-demand deployments. We've got a CI/CD. So this is your continuous delivery components such as Jenkins, Gogs, etc. We then have your CoolStore production, right? And that's the production environment for our CoolStore application with all the services deployed. We then have a CoolStore test, the test environment for the CoolStore application with all the services deployed to run user acceptance and system tests. and then we've got an inventory test and inventory dev. Is essentially a test environment for the inventory microservice in order to run integration tests, right? So now that I've taken you through what the different projects that I have in here, I'm actually going to jump into my CI/CD project, and I'm actually going to look at pipelines. So essentially, I've kicked off 3 different stages of what I want in my inventory pipeline, and you essentially can go and create a pipeline for whatever you wish to, right? So if I actually create, and if I open up any of these builds, I'll open up build 1. Essentially what it's going to create, you can go into the pipeline and create different tests for this environment, right? So for instance, you could create an inventory dev project, you could create deploy to production, not live, you could run tests in tests. So essentially you're creating a pipeline for testing something before you deploy it into production, right? So an inventory pipeline is essentially an OpenShift pipeline that takes any change committed to this CoolStore microservices project team in the Git repository through various steps until it's deployed through production, right? So the pipeline was obviously triggered by someone within the team, someone like a code reviewer or something of that sort, merge the pull request into the repository, and now the pipeline has taken the code changes and will take the code changes through dev environment after a test succeeded, right? So then it has promoted the changes to test environment to run the system integration tests with all other dependent services. So when the tests succeed, then the new version is promoted into production in parallel to existing version that is serving customers. So it is essentially waiting for the release of managers' manual approval to go live, right, and direct the production traffic to the new version. So essentially that's what will actually happen when we've actually got this whole pipeline created, right? So the manual approval is typically integrated into existing IT workflows, right? So, you would be using things like, maybe ServiceNow, EMC Remedy, Jira Service Desk. So in ChatOps, this step would be integrated into things like Slack or other chat systems, and that would be controlled via like a chatbot, right? So in this one, for the purpose of the demo, I just created it straight into Jenkins directly, and then just approve all the deployments, right? So I've kicked off the actual builds for the different, or I would say created the different pipelines for the different test phases, and you could pretty much define however and whatever you want included in those tests, right? So that essentially takes us through pretty much the OpenShift application platform, how the application was actually built. So just to go back here, that's what I used to build the actual application. That's what the actual application looks like. And then within OpenShift container platform, this is essentially how the actual application's actually deployed into a container platform like OpenShift platform. And hope I hope that you could have taken something, from this demonstration, at least giving you an indication of how OpenShift actually works, how you deploy microservices architecture, how you deploy containers, how containers work together to serve a bigger application.
That was great. Thank you so much for that wonderful demo, Pranesh. We've come to the end of the session, but as a call to action, I would like to invite you to attend this, book a session with us. You can discuss your container strategy in detail. If you want to be more specific to your own use case, we are glad to help you discuss more in detail and see how we could help you. Do look forward. So we have now discussed the app modernization and using containers, OpenShift, and how that's going to benefit you. But moving on to that, we would also like to discuss how you can also modernize and migrate your database. So the upcoming webinars that we have planned for you is going to be on topics like SQL Server on RHEL, on Azure, and on Ansible, which is going to be on automating your environments across. So the benefits you will see from this is, if you're looking at an end-to-end modernization, this is going to cover the rest of that story on looking at how you can get better, improved productivity from your data as well, and the databases that you run. So do look forward to that. We'll announce the dates very soon on that. Of course, we do have some resources here for you, so you're welcome to download the white paper and some more digital assets from Ripe. And feel free to contact our experts from Ripe, from Red Hat, as well as from Microsoft. All of the contacts are listed out here, so feel free to reach out to any of us. And as a team, we're available to help engage with you. So thank you once again, Pranesh. I think it's been a great series. Appreciate your time and to inform and give our customers and partners a demo of OpenShift on Azure, talk about the architecture as well as real life use cases. I think this has been extremely useful, and we look forward to doing more together.
Excellent. Thank you so much, Sindhu. It's likewise. It's just been a pleasure hosting this webinar series with you, and I look forward to the upcoming ones where we can actually deliver and show more value to our partners.
Yeah, stay tuned, everybody, and look forward to more that's coming up.
Yep, exactly. Thank you, everyone.
We will take any questions if there are any right now. So we concluded with that, but yeah, let's take any questions that the audience may have.